This is Alan Bertrand. I'm with the QA department at Eversync, and today I'm going to be talking about virtualization and how that impacts your backups. So let's get started here. Alright, virtualization, of course, has changed things probably more dramatically than almost any other technology that's been added recently to the IT world. It's had particular impacts on the way backups are done that require special consideration when you're planning a backup strategy. If you were to just apply regular backup schemes to your virtual machines, you might wind up missing data or duplicating data needlessly. And virtualization is just taking off as a way to make it easier to manage and control an IT environment and to split resources more granularly. So there are a few considerations particular to backing up VMs. First off, of course, if you were just back them up as a regular machine, which you could do, you'll encounter a few peculiar issues. First off, most virtual machines are sized to their workload, since it's easy to add a little more to them later without having to purchase hardware or mess with hardware at all. It's a lot easier to just make it just big enough to do the job, which means that doing a backup can push its resource uses over what it might have. And that, of course, could have an impact on the performance of that machine, or indeed the whole environment. There's a few other considerations. VMs use virtual disks, which, if you run your backup from within the VM, that gets hidden from you, but that presents certain opportunities for advantages that it's important to consider and to make use of. Obviously, because they're virtual disks, they can be moved around from one data store to another easily, even while the machine's running, which is something that you have to account for when you're backing it up. And if you're going to back up entire VMs, it can be a little tricky to get down to the granular level you might want when restoring some of that data. So, of course, because resources are shared between virtual machines within one physical host, there can be an impact between the machines affecting each other. And backup software agents will consume resources and use a lot of disk I/O, things like that, when actually performing the backup, which can have an impact that's much more noticeable in a virtual machine than a physical machine. And if you've got that going on several virtual machines on one host, the aggregate impact can be pretty big. And the virtual disks like VMDKs and VMware are usually created within a larger data store that's, again, you'll have several of that you can move back and forth. And if you were to back up that data store from a regular backup system, what you would get would be that virtual disk being one file or a small set of files, maybe a half dozen or so, files that just contain all of the data from that disk. But unless the backup system knows how to make sense of those files, knows what their structure is, then they just get treated like any other file. So because of that, even one small change, like a new entry added to a system log, changes the content of that file. Thus, it's a changed file, and you've got to back it up again. Unless you know how to determine just what parts of the file have been changed and back up and do that. Another key aspect to virtual machines that isn't common to physical machines is how easy it is to set up a new VM. You know, with a few clicks, you can have a new machine set up and ready to run whatever you might have need for. And if your backup system doesn't help make it easy for you to back up these new VMs, that's again another way that you can miss something in setting up the backup. And again, back to the issue of data stores, VMs can be moved around from one data store to another, usually through VMware's vMotion, which lets you make that transition without having to shut down the virtual machine. And that can get to be a little tricky for backups. If you're backing up that data store with a normal file backup system, you're going to wind up with the either getting the file from one data store and then getting that again from the other, or you'll miss it while it's in transit and not get it backed up at all, unless you take great care, which usually requires manual intervention. So of course you want it to be easy to back up and restore entire VMs, but if you've backed up a VM that way, it's usually not so easy to get down inside the VM and get an individual file. So if you've backed up a VM and you need just one or two files from it, unless your backup solution has a way of enabling that access, you may find yourself restoring an entire VM just to get at a few bytes of data. So, come on, go to the next slide. All right, so the general trend, of course, is towards more virtualization, but you're never going to get rid of the need for some machines to be physical machines. And ideally, of course, you want your backup solution to handle both. So we have a few key features in that regard. You want to be able to talk to the hypervisor. It's great to also be able to talk to vSphere, since that's going to track things like the vMotion. If you can get the application integration, which allows you to recognize the files that are part of a particular application within a VM to restore them. For example, restoring an Exchange database from a backup of the entire VM without having to restore the entire VM. You want your backup solution, of course, to support both virtual machines and physical machines, because even if you're trying to push as much as you can in virtual, you're going to need some physical machines. And especially handy with virtual machines would be deduplication. Since it's so easy to spin up a new virtual machine, and it might be, at least at the beginning when it's first set up, just like a lot of the others when they first set up. So you want to, of course, be able to talk to the hypervisor to minimize your dependence on having to install an agent on the individual virtual machine. And in fact, if you can do without altogether, even better. You obviously want to be able to get inside the VMDKs if possible and restore individual pieces rather than having to restore an entire virtual machine. And you want your backup to be able to take a snapshot of the VM and back up that snapshot. That way you can get a self-consistent set of files without interrupting the operation of that virtual machine. So if you can talk to the vCenter or vSphere system, that lets you access the VM in a number of ways and keep track of the VM even as it moves from one host to another or one data store to another, so that you don't have to worry about getting that same virtual machine backed up twice, or even worse, missing it altogether while it's in transit. And being able to integrate with vSphere, of course, lets you take those snapshots to get the self-consistent backup set of files. And then, as I mentioned, the application support, for example, Microsoft SQL Server or Exchange Server. This support lets you, when getting a backup of the VM, first signal the VSS system to signal, say, Exchange, for example, to save out its files in a consistent state before you take that snapshot. And it'll also create a sort of an inventory of what would be required to restore just the stuff that's part of that writer, so that you don't need to back up that database separate from the VM. You can get it all from that VM backup. And as I mentioned before, of course, even if you're going virtual, you're always going to have physical machines. And generally the balance now is more towards the physical machines. But either way, you want to make sure that that your backup system has you covered on either front. And of particular importance is the deduplication, since you're going to have a lot of data that's common between virtual machines. and even a lot of data that's common between virtual machines and physical machines. For example, all of the files that are part of the same version of the Windows OS are going to be basically the same on just about every machine. And so you really don't want to have to try to store multiple copies of that. And so for that reason, we've of course included a block level deduplication feature, which allows the system to identify individual blocks of data that are already stored, and just refer to the already stored version instead of storing it again, which can greatly reduce the amount of space required to perform your backups. So we've worked hard on optimizing for virtualization, while not compromising the ability to back up physical machines. Both, of course, are important to just about any IT department. So we're going to dig a little more into our virtualization features here. For the VMware integration, you need to have a licensed vSphere deployment. The trial version of ESX doesn't provide some of the APIs we need. It needs to be at least ESX 3.5, although some features require ESX 4, and I'll get into that in a second here. And we can talk to the individual hosts, or if you have it, vCenter, which enables a few features. So let's have a look at that. Over here in this window, I believe, yes. I have one of our appliances. Let's log into that. Alright, so we'll go over here, and I'm going to set up a connection into our vCenter. So I've just told it where to find the vCenter server, which is either creatively named vCenter, and given it the name and password for an administrator level account that can be used to create snapshots, access files, etc. We have the option to register all of the VMs that are found, but I've actually already registered some, so I'm not going to do that. Now I'm going to talk to that vCenter server and discover that I typed the password wrong, so I'll try that again. So it got the index of the list of virtual machines that are out there in this environment, and has created a handy list for us. You can set one up to be backed up simply by selecting it, registering it. Create a client for us with the default settings. Of course, configurable. We can change the schedule off from the default. Decide whether or not to use the change block tracking features, etc. And we can easily get a backup of that if I go back to the right place. Just tell it to bring it back. So it's going to talk to vCenter, tell it to take a snapshot of that VM, and then talk to the host, get access to the virtual disk for that VM, and start copying the blocks of data from that virtual disk. And in this case, because that host is running ESX version 5, well, this will work for anything from ESX version 4 up. It can actually specifically select just the parts of the disk that are in use. So even though that's a 2 gigabyte disk, if I've only written 1 gigabyte of data to it, I only need to transfer the 1 gigabyte. And I also have the option when doing the backup either from the schedule or manually, except I can't do that while it's backing up, to choose a differential or an incremental backup. VMware provides a feature called change block tracking that will keep track of what blocks of the disk have changed since this backup, so I can then do another backup of only those blocks rather than having to transfer the entire disk again, making incremental and differential backups pretty painless. So let's see, back to the slides. So again, as I mentioned, you might have games migrating back and forth between data stores. This, of course, is a good thing since it provides you with fault tolerance, makes it easy to do maintenance on the data stores, lets you balance your resource usage, that kind of stuff. But you want to be sure, of course, that this isn't going to cause a problem for your backups, which is important part of our system. Getting back out of this. See, it always knows what host and data store a VM is on, and maintains, keeps track of these things, so that if that virtual machine migrates before the next backup, we know where to find it. So as I mentioned, there's the change block tracking, which is a feature accessed through VMware's vStorage API for data protection, or VADP. This is only available if you have ESX version 4.0 or higher. But that allows you to skip parts of the disk that have never been used, or if you're doing an incremental or differential backup, allows you to skip portions of the disk that haven't changed since the last full or the last backup, depending on if you're differential or incremental. So as far as scheduling your VM backups, there's main consideration, just like with physical servers, is to consider how important it is, how old you can let it get before you need another backup. But the general recommendation we make is, if you're using the change block tracking, to get monthly fulls, weekly differentials, and daily incrementals. If you're on, say, ES5, or for some reason, other reason are not using the change block tracking, we recommend a weekly full backup of the VM. So let's have a look at doing a restore. Come in here to the jobs, and let's take this one. And I'm going to restore it. Could restore over the existing VM, but I'm going to create a new one because I don't need to replace that VM. Just for demonstration, choose what host I want it to go to, data store. I could put the virtual disks in other data stores, but I might as well just put them all together. Name to the virtual machine. And because it's just a demonstration, I'm not going to power the virtual machine on after the restore is complete. But yeah, we'll connect it to the network since that virtual machine is not much use without a network connection. And finish. It's going to go out, create the virtual machine, start copying the virtual disks into it. So go to the VMware tab. And see it's copying the virtual machine's VMDKs. And it's just that simple if you're trying to restore the entire VM. But suppose in that VM all I really wanted was a couple of files. Restoring an entire VM for just, what, maybe a few megabytes isn't necessary. We'll browse, go here. We're going to look in the files contained within the virtual machine's virtual disks. It's going to take just a moment here while it prepares the VMDK. It's going to mount it and give us a browsing window to see the files that it contains. Well, if you don't refresh page anyway, that may be the browser window. It's trying to interact with the webinar, so we'll go back and try that again. Of course, I can't do that while it's being restored. But when that finishes, we can go in there. It's the same browse window that you see for a physical client. So if you look at this physical client, browse into files, and restore either to the virtual machine or restore the files to a physical machine, or even just download them directly from that browse window. Now, download and you're set. Of course, in there you also get the option to restore application data, like Exchange databases. Now, of course, not everybody is using VMware for virtualization, so we do support simple Hyper-V setups. The backups are done by our standard Windows client installed on the Hyper-V host. That connects to the VSS service running on that host to get a backup of the virtual disks for Hyper-V virtual machines. And when setting up a connection on the host, it's done basically as just a standard server. So you come into the interface, sure, of course, that you select a backup using the VSS service, so that you'll get the self-consistent copy of the virtual disk for the VMs. And then you just back it up like you would any other. As far as storing goes, you can go into the browse, same browse and restore window I was trying to show earlier. Select the virtual machine's virtual disk, store it back to that host, and then on the Hyper-V host you can create a new virtual machine that uses that disk, and there you have all your files back from the backup. So the particular benefits of decommission on VM backups, I kind of went over before, but by reducing the storage space that's required to maintain your backups, it's important to note that it will increase the time that you can keep your backups before you have to cycle them out to be removed for new ones. Allows increased performance since there's a lot of writes that don't have to be done since you find you already have the data. And of course, that makes restores that much quicker as well. One key advantage, of course, is being able to make physical and virtual machines from the same appliance using basically the same tools. You get jobs and list for both. They can share schedules. You can schedule them the same way that for both physical and virtual machines. They show up just as clients like any other machine. They're just marked as virtual machines in the list. And talk to vCenter to keep track of your virtual machines, so as they migrate from host to host, we always know where to find them, aren't either wasting time backing them up twice when that's not necessary, or missing them out because they've moved it. Oh. And of course, store files from individual files from VMDKs without having to install an agent on the virtual machine. Just backing up the virtual machine files on the appliance provides access to the individual files contained. The Eversync data protection appliance, variety of sizes and capacities to fit your needs. You can automate it, schedules, have it email you if there's failures to back up. You have no tape, so all of the hassles that come with backing up to tape are taken care of by using disk instead. So you don't have limitations based on having to read it linearly or whatever. And even for archiving, you can archive your backup jobs onto an archive hard drive, either keep for long-term or take off-site for long-term storage. It can all be replicated to a remote machine to provide good disaster recovery. Lots of features. Of course, it's designed to be simple to set up. I probably think I demonstrated that very well with the VMware integration. You just log into the appliance, tell it how to log into vCenter, and tell it what you want up, and then the appliance will back up your VMs. This, of course, has the distinct advantage of not being licensed on a per-client basis. So you don't have to worry about, as you add VMs, running out of licenses to be able to keep them backed up. mentioned, you get backup, replication, and archiving, all from the single appliance. Well, two appliances for replication, since you have to have somewhere for it to replicate to. And you get smart integration with virtual machines, particularly handy for running Exchange or SQL within virtual machines. So by integrating with the hypervisor, vSphere, being able to integrate application level awareness in the VM backups, supporting both virtual and physical machines, all of that with deduplication makes for a pretty good combination of backup features. And I think that pretty well covers it. If you have any questions or anything, of course, our sales team is accessible at the phone number 888-264-5116, extension 1, or sales@eversyncSolutions.com. There's, of course, our website address, eversyncSolutions.com. And I'll take a moment here and answer any questions you may have here. Yeah, as always happens, I'm sure you'll think of something that I didn't cover or wasn't clear in a little while here. So if you do, again, our sales team will be happy to answer your questions. Get them at sales@eversyncSolutions.com or by dialing 888-264-5116, extension 1. Thanks for your attention on this. Again, my name is Alan Bertrand. I'm with the QA department here at Eversync, and have a good day.